We are now in Module 15. Module 15 is SQL Injection. Let's get started. With SQL Injection, we have 5 different learning objectives. Number 1, we're going to summarize SQL Injection concepts. Number 2, we're going to demonstrate various types of SQL Injection attacks. And then 3, we'll explain the injection methodology. And then number 4, we're going to look at evasion. So we've already talked about evasion before, but this time we're using SQLi, SQL injection methodologies for evasion. And then lastly, we'll explain SQL injection countermeasures. Let's get started. Our first learning objective is just to summarize some SQL injection concepts. And so let's have a little bit of a look at SQL injection. So the question is, what is SQL injection? Sometimes you'll hear it called SQL injection. And in reality, Microsoft was the first one that I know of that first started calling it SQL. So you'll hear it interplayed between the two of those terminologies. SQL stands for Structured Query Language, and it's the language spoken by RDBMSs. An RDBMS is a relational database management system. And so what happens is we have tables that are in the RDBMS. Those tables are interconnected and contain information like usernames and passwords, etc. So what we're going to do is we're going to use a SQL command from the app and pull information from the database or bypass authentication, etc. Why does it work? Well, one of the main reasons that you see right here, because of unsanitized input vulnerabilities, and you can gain unauthorized access, you can bypass authentication, you can dump information, get stuff about the users, the accounts, the credit card numbers, and just really do almost whatever you want depending on how badly protected the application and the database are. So we do want to understand SQLi, and in fact you see how it kind of dovetailed into application hacking because we use some injection techniques for application hacking also. All right, so this is just a little bit of an explanation about how all this stuff works. Let's go over here to the far right side here. And what we'll see is that we have a username and password. So what's going to happen is the user is going to put this information in. And then what's going to happen is the app is going to create what we call a dynamic query. The dynamic query is select count from users where username equal Peter, password equal Peter, right? So that's what our query is. This query did not exist before. And by the way, if you are unfamiliar with SQL and you want to follow this module, there is a really cool website called W3 Schools. And just go to their SQL page. You can look up all these commands if you're not familiar with them, because we're going to get very deep into the weeds in this module. All right, so we do that, and then what's going to happen is it's going to send that inquiry into the database. It's going to look in that users table, and it's going to look for a username column in that user table, and it's also going to look for a password column, and then there's an and. It doesn't say or, right, one or the other. It says both of these have to be there in the users table. And if both of them are there, then the database is going to do something very, very important, and that it's going to return a yes/no condition, right? Computers do 1 or 0. And if it is both of these are in the database, then it will return back a true. And if not, it'll return back a false. And that's going to be super important as we get deeper into this module. Another one that we can do is, this is another injection query. And so in the username field, we put in blah See that little tick mark? Or 1 equal 1. Now, I want to also warn you about the lab. So if you're doing the lab, make sure that you have your spaces and uh, tick mark. I remember I had somebody in one of my classes, I think this has happened a couple of times, where they thought that the or here meant that they could put in either side of this. They didn't understand that was part of the SQL statement. So double quote, blah, tick, space, or space, 1 equal 1, and then that double dash. So what we're doing here is we are giving the parser a chance to either calculate what's on this side or on this side. And the tick really means nothing. The blah means nothing. So it's going to go to this side, and it calculates 1 equal 1. Now, if I'm a computer, am I going to return a true or a false? Oh, I'm always going to return a true. 1 equals 1 everywhere in this entire universe. 5 equals 5. When something is always true, it's called a tautology. So that's what we're doing with this. So now we have this double dash. And so when we do the query gets produced by the app, we have select star from users where username equal tick blah or 1 equal 1. Oh, but then we have a double dash. What that double dash says is the rest of the SQL statement is now a comment. So it's never going to ask for the password. We're commenting that out. And so that's what you see that we're doing here. And those dynamic queries, we're manipulating them to be able to inject something into that database. Okay, so now we are in Objective 2, and here we're going to demonstrate various types of SQL injection attacks. What I would like to focus on in the last objective and in this objective, these are the main corpus of information that you're going to need for the exam. Now, obviously, every single line, sentence, and character is fair game on the exam, but understanding some of these basic concepts is extremely important for the exam. Okay, so we're going to start with an overview of what types of SQLIs there are. So we have in-band. So with in-band, we're going through the app into the database. And those are going to include error-based, union, tautology. We talked about that term there. End-of-line comment, we saw that double dash. There are more versions of that. Inline comment, which is usually going to be a /*/. We'll see that later. And then piggyback queries. And then with error-based, we have stored procedure and illegal, illogical. On the other side here, we have blind or inferential. So what's going to happen is we're going to get a response back from the SQL server that means nothing. So we are going to have to use inference to figure out if our hack worked or not. With time delay, Boolean, and heavy query, all of these are going to play into it. So just to give you a little bit of warning, I'm going to, in some of these cases, do a little bit of a dive into the meaning of the code. In other cases, we're going to overview it. All right, so let's get started looking at this. And we're going to start with error-based SQL injection. So what we're doing here is we are forcing the database to do some type of operation that will result in an error. And in this case, if you look at the core of this util and attr get host name, if you are a database developer, you'll recognize that as an Oracle function. And the core of this is we're looking for a host name with the user database name. So wait a minute. So I'm using the user database name to look for a host name. What I'm looking for is to get an error, and the error reveals information that it shouldn't. And that is what we get here. That is host Scott unknown. I just got a name. That's pretty cool. So and the way this works is actually pretty masterful. I wish we had time to go through every single code snippet. But anyway, that's what we're doing, forcing an error. The next one we see is union. So with union, what I'm doing is I'm taking my own query, and I'm using the union operator to add my query to the original query. So in this case, we have a select name, phone, address from user. So that's the name of the table. And these are the name of the fields in the table. Where ID equals some $ID. The $ID is going to be a variable that's going to take an input ID. And now we're going to add in, see that $ID equal one right there? One. Union. Hey, now I can put my own query in there. Select, yeah, I don't care about user IDs. I want credit card information. And so I select information from the credit card table, and then it pulls up credit card information for me. And then we have blind or inferential. And so if an application is vulnerable to that, I'm trying to manipulate error messaging and error message functionality, I guess you could say, because of the time differences between the way the SQL server interacts. So we're going to see this in just a little while. So on this side, we have no error message returned. So let's say that I have a web app at Certified Hacker, and I issue an SQL command, drop table orders $. And so what if it actually deletes the table? How will I know? Well, it's possible that I'll get a generic error. Like for instance, it might, by the way, this is not generic. This is a pretty specific. So this is nice. This is nice. I like this because I can take information from here and tell exactly what's happening. But normally, you'll get an error like this. Oops, we're unable to process your request. Please try again later. Irrespective of what I do, I get the same generic error. And so that's why it's nice to use these time-based errors, because it takes a different amount of time to produce an error than it does to produce a result. And also, I can wait for a delay and if exists, construct to get yes and no answers. So if it's no, it'll say we're unable to process your request, try back later. If yes, then it'll sleep for 10 seconds. And then after 10 seconds, it'll display we're unable to process your request, try back again. So I can get yes, no queries by running a wait for delay. We'll see this used over and over again. Another type of attack we can do is a Boolean exploitation. And another one is a heavy query. So with Boolean exploitation, I'm using Booleans to cause behavior in the database. So for this one, what I'm doing is after the ID equals 67 in the parameter section here, I'm doing and 1 equal 2. Let me ask you a question. I know that you are pretty good at math, and so I'm sure you can answer this question for me. Does 1 equal 2? Wait, no? Okay, so when does 1 equal 2? Yeah, absolutely. Never. It never equals 2. So this is the opposite of a tautology. This will generate an error for sure. And so we execute that query, and then we can use that to characterize the database. And then we have heavy queries. And so in this case, we're using time delays, large time delays, or huge repeating cycles, multiple joins on a system. Again, we're using this to characterize the database, find out its limits, etc. Okay, so what methodology do we use for SQLi? And this is what we're going to be talking about in number 3. Let's have a look at how we're going to move through this. We're going to be, first of all, gathering information for vulnerability detection. Then we're going to launch the attack. And then we're going to have a little bit of overview of some advanced SQL injection. Let's start with identifying the entry paths. And so what we're going to do is use Burp Suite. We've talked about it in the last module, used it in the last lab if you were following along. And with Burp Suite, we can find out where all the parameters are, where we can put data into the database. And with TamperDev, it does some of the same stuff, characterizing the inputs, etc., and allows us to decide where we want to start. Another thing that we want to do is extract information through error messages. And so we're going to just tinker with everything for a while. Parameter tampering. So we see here where we have certifiedhacker.com download PHP. Yeah, that question mark right there. ID equal car. Let's try horse. Let's try book, etc., and see what type of response we get. We're going to extract information, try to see what type of errors we get. Are they generic? Are they verbose? And then we can do things like determining the database engine type and trying to get it to return an error that tells us the type of a server that we're using. One of the items that you'll see is a constant in this is in order to do that, what we're doing is using things like tick marks, these single quotes, and semicolons, and double dashes, ands, and ors, etc., to try to get a nice little ODBC error that'll give us more information about the database engine. We also can do grouping errors. So let's just kind of zoom in on this code and have a look at what we're doing here. So we have two different things we're looking at. Number one is a grouping error, and the other one is a type mismatch. These are methods that are commonly used for SQLi. What we're trying to do is gather information about the database schema. We're trying to find column information. We're trying to find tables. We're trying to find structures and so on. And so let's look at the first one. This is a grouping error. So grouping in SQL. So when you do a group by operation in SQL, all of the columns that you select they're not aggregated, like for instance, sum or count. So all of the columns have to be included in the group by clause. So if a column is missing from the group by clause, the database will generate an error. So the attacker is going to create a query deliberately that causes a grouping error. And by crafting this statement, create the deliberate error. And so in this code that we see here, what we're going to get back is a message that exposes that there are columns in the query that haven't been properly grouped. And what this does is it gives us some really nice information. So that's what we're trying to do. Make sure that we leave out certain things so we do have a grouping error. The next one we're going to be looking at is a type mismatch error. And so if you look at this, we have different types that we can use. A data type is, for instance, a numerical data type might be an integer. It's a 1, 2, 3, or 5 or something like that with no decimal point. We also have floating point, and we have a double float, and we have things like string values and so on. And so in this case, we are going to force a type mismatch error. And in a lot of cases, that typing is strictly defined. And so if you put a query together with the wrong type, like attempting to put a string into a numeric field, then we'll get a mismatch error, and then you take advantage of that to force a specific type of error. So what we're trying to do with this one, with this type in mismatch, notice we're using a union onto the original query. And this one gets information about the expected data types and maybe a little bit more about the structure. Look at credit.aspects, line number 17. We get a little bit of the structure of the database also. So what we're doing here is we're forcing through deliberate errors information disclosure and exposure from that back-end database. And that's just one of the many steps we're going to do to make that happen. Okay, so this list, let's go over every single tick mark. And no, we're not going to look at this whole list. I just want you to see that we can test in many different ways. And a lot of these are used for different things also. I mean, like for instance, if you look at these testing, these are used often to bypass authentication. And then we have others for many other purposes. If you go down into your student resources, there's an entire cheat sheet that you can use for SQL. The next thing we have here is we're going to use more methods to find out more about this database, including function testing, which is like parameter tampering, where we're putting different information into this database to see how it functions, what it does with it, and so on. We can fuzz test it. We can SAS and DAS. We talked about this in the last module, static and dynamic testing. So those are some things we can do. Also, you could do black box pen testing. This is when you know nothing about the database. And so what you're doing is you're feeling it out. You're checking to see what it is, how it works. And so one of the first things you do is you input tick marks and double quotes. So like you have a username and password. So tick, tick, or quote, quote. Or maybe you want to detect input standardization. So you can use things like braces and brackets and curly braces to see if it allows it. You want to see if there's truncation issues. So, hey, you click into one of the fields of the app and just roll your face on the keyboard and see how long it lets you put junk data into there. Maybe the first name field allows 255 characters. I don't know about you, but I've never met anybody with a 255 character first name. Rumpelstiltskin, that's still not, that's not that long. Then we look for modification. So we use square brackets and so on. And what we want to do is max out the return values for replace, max out the return values for quote name functions, look at truncation, what variables are used. So again, we're characterizing it. And then we look for injection vulnerabilities. Source code review, analyzing that source code, like we were talking about in the last module with things like Veracode and cover tree scan and CAST application intelligence platform and many others. Again, static and dynamic code review. What we could do now is get lower down and create a series of queries that will help us to get all of the components of the database that we want one bit at a time. Let's have a look at what some of this code does. Okay, so as you notice, we are moving through several different areas. We're starting with extracting the database name. And then from there, we're going to extract that first table. And then from there, we're going to get the column name. And then from there, we're going to get the first row. This is very typical of how we do this. So when we extract the database name, we have a URL that's we're putting together to trigger an SQL error. Why? What are we doing? We're converting, see this DB underscore name? We're converting this to an integer, and what's going to happen is it's going to result in an error. And if we get that error, it might actually dump the database name and give us that information. What about the next one? Extracting the first database table. So in this little bit of code here, what we're doing is we're trying to go get the name of the first table from the database, but we're going to select it and we're going to convert it to an integer, and we get an error that might reveal the name of the first table in the database. Down here, the first column name, this URL is trying to extract the first column name of a table, which is table-name, by selecting it and causing a conversion error, disclosing the name of the first column. And then down here, same thing, right? So what we're going to do is get the first value field from the first row of the data in this table, convert it to an integer. It's going to fail. It's not an integer. It's a string or a different type of value. And the error message just might expose what the actual name of whatever these things are. So we're iterating through a process one little bit at a time to extract this information. When we get deeper into this, you'll see that this iterative process is exhaustive. We'll look at that in just a few moments. All right, the next thing we want to look at is the idea of doing error-based SQL with stored procedures. What is a stored procedure? A stored procedure is, doesn't tell you about it on the slide, but it's kind of like a little mini bit of code, not quite like a script. And you'll find them in like Microsoft SQL Server databases. There are some default stored procedures, and then you can write your own depending on what you want to do with that database. So let's have a look at doing error-based stored procedure injection. And so over here on the left, what we're doing is the stored procedure, what it's supposed to do is log in a user by checking the username and password against a database. It builds a query dynamically. It concatenates the username and password into a query string. But But this is vulnerable. Why? Because the user input into this is not sanitized, making it vulnerable to people like you who are learning about SQL injection. So an attacker could easily inject SQL code into the username and password fields, bypass authentication, and then execute commands. So what you can do as an attacker is you can do that or 1 = 1 tautology with the double dash at the end and insert that in there and get in without a password. But if you look over here, we have another dynamically created, well, a dynamically used stored procedure, generating an SQL query based on listing the number of columns provided by the user. And it's supposed to generate a report. Here's the user input down here from a table. And the purpose, what we're doing is selecting specific columns. The query string that we're looking at is built dynamically, but this is vulnerable to SQLi because you can include whatever you want, commands in there. So you can input, like for instance, update users or set password equal password or select star or whatever as part of the column list. And so both of these really are showing the dangers of not sanitizing user inputs when using dynamic SQL in stored procedures. So you have to be careful with that. What about other types of injection? And what I'm going to do in this one is let's look at the overview of what's happening, and then we will spend a little bit of time looking at what these do. So the first one is extracting the database name. We're going to see this over and over again. We're going to do it in different ways. There are similarities, but a lot of differences. The next one, we're going to extract the tables from the database. And then we're going to extract the columns from the table. And then we're going to extract the first field. And then we're going to extract the second field. And then we're going to extract the third field. And then we're going to iterate to the next table. And then we're going to, so it takes a lot of iteration. But let's step over to my computer here and zoom in on a little bit of this code. So we're going to extract the database name. So we see this URL again popping up here. And then what we do is we union. See that union there? We're unioning a select statement to merge a query. The query is going to fetch the DB name within the original query. And what the result is that the database name will be returned. Over here, next one down is we're going to try to extract tables. And again, we're going to union select and merge this query with the table names from the sysobjects table, where the table type matches this car 85, so within the original query. And what we're trying to do is get it to give us that employee table down here, extracting the column names. Again, we're going to use a union, select, and merge the result with the original one. What we're trying to do is grab those columns. So each one of these is a union select to try to gather specific information, one value at a time. So like I said, it takes a while. It's pretty exhaustive to make this happen. And this is why we have tools. We're going to talk about tools. We're going to talk about automation because you don't want to just put this in all yourself. All right, let's go ahead and look at a few other items that we can do. In this case, we're doing blind SQL injection. Again, still doing a lot of blind injection. And what you'll notice in this one is embedded in here are the ASCII characters. So in this case, I'm looking at one character at a time. What I'm asking, is it an A or not? So that's that 97. And it'll evaluate to true or false. And I get a different response if it's true and a different response if it's false. Right. Oh, it is A. Very nice. Let's go to the second character. Let's find out if that is A. Is it A? True or false? I get a different response as I go to the second and then a third character. And we iterate through that over and over again. I mean, it goes insane. Check it out. Look at this. I'm just looking for the username length. And here is it 1? No, the username is not 1. All right. Is it 2 characters? No, it's not 2 characters. Finally, what if the username is 15 characters? I'm going to have to iterate through that 15 times. Now, okay, now I can see It's 15 character username? Okay, good. Let's go through the first one. Is the first character A? All right, let's use that substring, go pull that from the user. We run the wait for delay. We get a true, false, a different response if it's true or false. Oh, it's not A. Well, let's see if it's B. And anyway, you can iterate through all the letters in the alphabet, find that it starts with a Z. And then we go for the second character in the username and the third character. In our case, with what I was talking about in this first area, we're going to have to do that 15 times. Isn't that insane? The matrix of the number of operations required is pretty fascinatingly large. And then we're going to see if we can grab the database name. And again, we're going to iterate through one character at a time until we find it, making use of that wait for delay so we can get a differential in the responses. Then we're going to try to extract the first table. Then we're going to try to extract the first column. Notice all this substrings. I mean, it's pretty amazing how deep this goes. But the point I want to make with this is it takes quite a huge number of iterations to pull out all the information you need and characterize that database. And then we can actually extract rows, first row, second row, etc. And there is a little bit of leeway that we can make use of in some cases, rather than just going from the A and then is it B, is it C, is it D? What we could do is we could say, hey, is it somewhere between A and F? Hey, that's better, right? That cuts it down. What we're doing is we're using regular expressions. Regular expression helps you search for text strings in certain ways. And so that makes it a little bit easier using regular expressions, looking for values in MySQL. Wow. So that is, we've been talking about blind attacks, but there's the idea of a double blind attack. Let's explore that. So here we have a double blind attack. Why do we call it a double blind attack? Well, a blind attack is when we are not getting a direct response from the SQL server. The SQL server is giving us something that doesn't give us the direct information, like a generic error or nothing. So the term double blind for SQLi really takes us into a more advanced technique. What we're seeing is I, the attacker, can't see anything, and the system doesn't provide feedback. So the attacker nor the system provides any direct feedback about the success or failure of the attack. So as the attacker, I don't receive any error messages. I don't receive any output. I don't receive any obvious indicators that I would normally confirm whether the SQL payload worked or not. Instead, I need to infer the success of my attack if I'm the attacker through signs. For instance, using those booleans and so on, maybe changing response time, application behavior, etc. Let's have a quick look at this code. This is actually a fairly sophisticated command here. It's very, very interesting. So what we have is we have an if condition right over here. We're going to check the first character of the password. We're going to see if it does or does not have an ASCII value of 97, which is, of course, A. And then we have a benchmark function right over here. And if that evaluates to true, it's executed, and it deliberately slows down what's happening on that server by doing a huge number of operations. The number of operations here is 2 million of this MD5 now function. So what are we going to do with this? Well, we're going to look at the response time that we get out of this code. And if it's delayed, then it was true. And if it's not delayed, then it's false. So again, because I don't get any feedback and the system itself doesn't tell me anything, this is double blind. We have other techniques that we can use. These are out of band. Remember, in band is when I'm going through the app into the database, following the path of the app. out of band is when I'm using some type of other functionality to get at that database. And so, for instance, we might make use of HTTP, as we see in this one, or down here where we're making use of DNS to try to find information, or maybe commands that will run on that server. Then we have second order SQL injection. With this, what we're going to do with that backend database is we're going to store something in the backend database, and then we're going to use a query that depends on what we stored in the backend database. That's a second order. We can also use various methods to sneak our attack across the firewall. So there's an application firewall, some type of firewall. So what we're going to do is use normalization. And so what we see with this one is we change that structure of the query to make the attack sneak across. You see how we're using the slash star star slash? These are inline comments, and we position them in such a way that the commands that we're trying to execute are not commented out, but it fools the web application firewall because it thinks that it's looking at comments. And so we have the HPF technique, where we are using it along with the HPP technique and the union operator. And for both of these, what we're doing is we are overriding parameters and injecting characters into the query strings. And of course, we go back to what we were talking about before with blind injections. And this is very similar to what we were looking at when we were going through that code. And what we're doing in this case is using that construct to do these logical and/or requests, and again, to try to get around the firewall. There are some more like signature, CRLF, buffer overflow. The first one we see here is a signature bypass. And what we're going to do is modify the structure. That's what that signature is. It's a structure of the SQL query so that it doesn't get picked up by the firewall. And so what we're going to do is alter the syntax in order to make it so it doesn't show up. And so let's start with the buffer overflows. And so the buffer overflow exploit is going to exploit vulnerabilities in the firewall's code because it's often written in C or maybe C++. But what we're doing is we are sending it more data than it can handle. And what we're trying to do is cause that firewall to crash or to behave in an unexpected way. And then we go back to CRLF, the character return line feed. So what we're doing here is we're inserting those into the URL and trying to bypass security, make it look like it's not harmful. And over here in the integration method, we are using, again, signature bypass and CRLF, both of them to increase the likelihood that we'll be able to make it past that firewall. If you look at this one, we have a few others. We're trying to find user privilege. We're trying to look at the DB structure and DB administrators and enumerate columns. So let's have a look at what's going on here. So the first one we want to do is use various methodologies to identify user privilege. And so we can use the function right down here, embedded in here is user, right? So we're going to use that. Also, there's another one, current user, session user, system user. We're trying to find the privilege level. So it helps us to understand what's going on, who's doing what, etc. And then we look at, like, for instance, DB administrators. And one of the things to keep in mind, if you look at this top line, is a lot of databases by default are using DBA, DBO, admin, or other types of users, root. And so what we're going to do is try those out, find out if those are actual users. The next thing we want to do is find the DB structure. And so we're going to use SQL commands to identify the structure of the database. We're going to try to find column names you see over here and find tables. and enumerate those. And then if you look at the last one here, we're going to, under the auspices of multiple types of databases, send in queries to list columns in a table, mapping out the schema, mapping out how the database is put together. So again, we get more information, pop it into how we're storing information about our hacks, and make sure we can go back and reference that as we get deeper into hacking that database. All right, so other things we could do, advanced enumeration. So we can use advanced techniques to enumerate columns in one query. We can enumerate databases. We could do password grabbing. And so if we look at some of these queries in particular, we'll see that, like the first one here, tables in columns. This one here, look at that. We have syscolumns, sysobjects, sysobject ID, syscolumn. It's all this. We are combining multiple system tables to list out table names, column names, data types in a single query so that the attacker can quickly map out the structure of the database. And then we have database enumeration, and we're listing all of the databases on the server. How are we doing this? We're querying the master DBO sys databases system table, which will help us identify the databases that we might be able to hack. And then we're doing some password grabbing over here. So if you look at this code, what it's doing is trying to get usernames and passwords from which table? The users table. And so we can grab that information from there. So we have a variety of queries that we can run to make that happen. And then if you look over here, we're grabbing hashes. And so what you want to do is extract hashes. Where we're getting these from the syslogins table, which stores a login information in a Microsoft SQL server. The query is going to retrieve passwords from the password field. And then there's a hexadecimal conversion that we're doing, extracting the binary hash. We're going to convert that to a hexadecimal format, and we're going to run a loop for that. There's a looping structure that we put together for that. And then the code iterates to the length of the binary value. There's that at length that we're using for that purpose. Eventually, we extract hashes. And then if you look at the end, we have the extracted hashes through error messages. There are ways that we can iterate through and extract even database hashes. This one is very interesting. This one depends on you already having a pretty good degree of ponage for the database. You have to be able to have some privileges on the database. But what I like to say with this one is, hey, you don't like sending in queries remotely all the time? Well, just copy the database to your own laptop. And that is using this little cool tool called OpenRowset. And so what we're doing is we're using port 80, and we're giving, look at this, we do have some ponage, all right? We know the user ID and the password, and then we tell, hey, copy this table to my laptop, and then copy the next table, etc. That's what we're doing with OpenRowset. So you can replicate the entire structure of the database onto your own location. And then we can also use commands. And this is one of my faves, is to interact with the underlying operating system structure. A couple of different ways of doing that. You want to interact with that OS. You want to give commands to the OS. If you look at Microsoft SQL Server down, right over here to the left, we can use a very powerful command called xp_cmd shell to execute commands in the server. And in this case, what we're doing, if you notice this, look at this, exec master xp_cmd shell. Look at that. That is an operating system command. ipconfig, that's the direction operator. We're moving that into a text file and then commenting the rest out. So we are running an ipconfig on the underlying system. And so we'll see a lot of different interactions where we can actually do that depending on the ponage of the SQL server. And then we have MySQL, where we're going to look at some custom functions, sysexec, syseval, and we can execute commands on the OS using these. And there are lots of commands like xp_cmd shell or sp_cmd or a create or sp underscore execute script or xp read and dir tree and log event. So it's not just one command. There are a series of commands that you can run on the underlying operating system. And that leads us to even greater exploits, because what I can do is I can use the load out file or into out file to take the information that I find and just put it into a file, dump it into a file. You see here we do a null union select load file, and we put etc password into a file. So there are many different ways of doing that with out file. And then we have a reconnaissance. Again, depending on the level of ownage that you have on that database, you can do things like scan the network, run NSLOOKUP ping, FTP, TFTP, SMB. You can test a firewall. You can scan the network with netstat, route print, and so on. Do reverse DNS, again, using that XP underscore CMD shell command, reverse pings, and then take all that data and copy it into a table and then open row set to your own machine. It's pretty amazing how you can do this. You can even create backdoors. This first one is getting an OS shell. When we go to get an OS shell, we're going to essentially create a PHP shell. And so what we see here is we're going to use SQL injection to create this shell. If you look at the select, got that PHP exec, and look at that right there, CMD. This is another part of what we're doing. We're creating a PHP file. That PHP file is going to be called shell.php on the server that can execute any command that we pass through the command parameter right here. And essentially it gives the attacker complete remote control. Very, very cool stuff. So what I can do is I can go grab all kinds of information from that through the XP underscore CMD shell capability that I now have, doing that reverse shell back to that attacker machine. Great stuff. Creating this backdoor. So we can create a backdoor in the database. In this case, we're using triggers. And so what we have is a little bit of code right here. Look at this. Create or replace trigger set underscore price after insert or update on item. So that's what that's a little bit more to that command, but that's what we're doing. So what this does, the trigger automatically sets the price of any items in the items table. Where is it? Look at it, set price equal 0 after any insert or update operation. So the attacker is going to use this method to manipulate data within the database without any direct intervention. So yeah, you can do some pretty advanced injection, and putting these commands together takes a little bit of work and a little bit of knowledge of how SQL works. And another thing to keep in mind is there are many flavors of structured query language, like Microsoft's is called T-SQL, and then you have PostgreSQL and MySQL and many others. And so sometimes you have to take that into mind when you're working on hacking the database. One of the nice things, though, is you don't have to do all the work. That's great. In fact, my fave tool is SQL Map. SQL Map can iterate through a database. And remember those deep iterations we're doing over and over and over and over and over again? Well, SQL Map can do all that for you. We're going to be running it in the lab. There are others like Mole and JSQL Injection and NoSQL Map. And by the way, NoSQL databases are hackable also. NoSQL means not only SQL. So it uses a little bit of a different format for the language. So there are plenty of tools that we can use to hack databases. But we have these days the best tool, which is AI, specifically working with LLM. So in this case, check for all possible SQL injection on this target. In this case, it's going to use, we didn't tell it to use SQL Map, but that's what it's using for that purpose, and iterating through and finding what types of injections can happen. Over here, we're doing multiple Boolean-based SQL injection on target and enumerate database tables, user tables, etc. So we are giving it multiple commands, and it's going through and enumerating these things. Another thing that I would do on this one is I would have it output it into a place that would be easy and convenient for me to keep track of. And in this one, perform an error-based SQL injection on the target URL with parameter, etc., and enumerate the tables, right? So that's good. We can do and actually have it do many other things. And if vulnerable, enumerate the database. So we're going to start with a error-based SQL injection. So we take all these terms, and this module has all kinds of information in it, but we're talking about error-based injection. So even if you don't remember exactly how it works, you can have the LLM do it for you. Over here, time-based. Check for time-based blind SQL injection on the target. So we have it run through that. It goes into SQL map and does all the work for you. Check for union-based SQL injection, giving you the parameter and enumerate the database, right? So again, we do that with the databases, with AI, with the tools that we have available. Okay, here in learning objective number 4, we're looking at demonstrating different evasion techniques. When we're talking about evasion, we're trying to get past IDSs, IPSs, and firewalls. All right, so let's have a look here. Oh, I love this. This is kind of like an overview. If you look here, what we have is the attacker. We're trying to injection attacks going through the internet. Oh, there's a firewall. Oh, there's a filter. Oh, there's somebody like me, a security admin. And we're trying to protect this web application, the database, protect the actual data, stop OS shells from being used, protect the backend network. We're trying to stop all that from happening. Meanwhile, this dude right here just needs one opening. So we have quite a lot to defend. But let's talk about some of the techniques that we can use. We've seen this before, and this is encoding. So we saw that with the inline comment, trying to break things up. Look at that, SEL, ECT, breaking up that pattern. Encoding characters, so we're using ASCII or UTF-8 or something like that to encode the characters that we're sending in, right? This is not character encoding on the application server. It's a little bit different. We're using string concatenation. This is a concatenation operator, the double hockey sticks right here. And instead of select star from blah, 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 database, SEL, concatenate with ECT, it gets to the app server, the database, and it does it for you. But the application firewall can't see it. We can obfuscate the code with various ways. So for instance, we have hexing and unhexing going on here. We can use signatures, use modification of the code to avoid signatures. In this case, we're using concatenation and hashing and a variety of tools. We can use white spaces. So this one, instead of using concatenation, we just put a big space there, and it doesn't trigger the IDS or firewall, or we encode it in hex. So it just looks like a big hexadecimal string. And again, it doesn't trigger the application firewall. And we can use sophisticated matches. So if my firewall, I'm testing it, it doesn't let me do a tautology like or 1 = 1 because it's matching that pattern. So instead, what I do is I use or 2 = 2, or 10 = 10, or John = John, right? That's equal. Or 7 is greater than 1. That's always true. And we'll get the tautology through in another way. Or we can use URL encoding, obfuscating the string by replacing it with ASCII characters, and then using that little % sign. That's part of the ASCII character encoding. And then we can take for instance, a SQL injection query like this one, and then boom, put it all encoded, and then encode that, double encode it. And then let's see if the firewall can figure that one out. We also can use null byte and case variation. So let's talk a little bit about null byte. So with null byte, um, we find that we were already talking about something somewhat similar to null byte, that's CRLF. So let's have a look at what we're doing with null byte and then compare the two. So a null byte, what we're going to do is inject that %00 into the query to bypass the filter that's looking for a certain pattern. So what null byte does is it's a string terminator. So anything after the null byte might be ignored, including my malicious code. I think we've already talked about case variation. If not, look at the bottom right here. Union, select, etc. And we're just varying the case. And so union select doesn't get picked up by the filter. But null byte is this %00, and it's the end of a string. It's endemic to C-based languages. And CRLF is a character return line feed, and we don't see it on this slide, but we were talking about it earlier, that we use to manipulate HTTP headers and other text-based protocols that by injecting new lines. So null byte is kind of a lower level. It is used to truncate strings, bypass validation, but CRLF is used to give you a new line, just like that typewriter. And then for both of them, after terminating or getting a new line, you put in your own hacker stuff, and that gets executed instead. All right, so we can also, hey, this is actually cool. I like this one. So you can't get it across the firewall or the IDS. So you take your hack, you put it into a variable, and then the variable is expressed on the other end, and it runs your hack. We also have IP fragmentation, where we break it up into a small chunks that don't get reassembled at the firewall, but they make it to the application server where they get reassembled and the attack occurs. Okay, so we are at objective 5, and we're looking at countermeasures. Just like with the previous module, I want to warn you about some of these countermeasures. We're not going to go in depth into every countermeasure, but we will overview it. And this is something you want to discuss with your DB team, your dev team, if you're doing this in the real world. All right, so how do we defend against SQL injection attack? Essentially, what you want to do is monitor everything that's going through that app into that server. Strings, different types, looking for sanitization of everything, looking for making sure that, like for instance, all your fields have specific restrictions, making sure that you are running detection systems at all times, and then you're testing it yourself. You want to make sure that you have escape sequences. You want to make sure you're running secure hashing and encryption where it is needed. Be very careful with the way that you use regular expressions and handle user supplied data. You want to make sure and write secure code also. Let's have a look at this code and see what's the problem with it. So here we have a parameter. So we want to defend against attack. We want to use type safe parameters. So if you look at the code here at the top, we have a new SQL adapter, etc. This code will take user input from login text, and it concatenates the user input login.text directly into an SQL string. And then the resulting string is executed by the database, and it's vulnerable. This is the actual code that we're seeing here. It's vulnerable because the user input isn't sanitized or parameterized, so the attacker can inject whatever code they want in there, like drop tables or something like that. So the secure code that we see on the right, you notice that there's a little bit more code there too. What it does is the code parameterizes queries instead of embedding the user input directly into the SQL query string. And so it defines that output right over here as at AUTID and assigns the user input to the login text variable. And because it's parameterized, it's more secure. Parameterizing your queries makes for secure code. All right, so let's have a look then at other things you can do to defend. Validate your input. And what we're looking at here is some regex to look for certain types over here of things that you don't want, characters you don't want, patterns you don't want on your system. Whitelisting, looking at encoding the output. We talked about that in the previous module. Least privilege in terms of accounts, maybe even rename your accounts. Like clauses, what they do is they help replace wildcard characters, which are often used in attacks. Wrapping parameters with quote name and replace. So what this does is helps to make it so that certain types of commands can't make it into that database. We also have more regex here. So what we're doing here is we're looking for patterns that you often find for SQL attacks. This is just showing some of what each one of these characters mean, and we use these to filter out an attack. And then we have tools that we can use. OWASP ZAP we've talked about before. DSSS is a nice little injection vulnerability scanner, so we can use that to look for vulnerabilities in the database. And back to good old Snort. We can create Snort rules to, this is a pretty good one here. So we have a few rules to help make sure that we are not vulnerable to SQL Server attacks. We have 2 of them there. Burp Suite, SQL Invader, and other tools are available to defend your database. SQL, it's actually pretty amazing. I don't know about you, but I remember studying SQL, been using it for quite a while, and you can do quite a lot with it. You can create these huge databases, and more lately, dealing with big data and data lakes and so on, it gets pretty crazy to make sure that you defend everything. But for a large number of simple RDBMS systems that are unprotected, these hacks work. And so it behooves you to learn to use those. So join me in the lab. You want to get these labs done so you can understand how it all works and how it's all put together. And then after you do the lab, or maybe if you want, you can just drop into the next module with me. And if you want to do that, we'll see you there.